This is a video demonstrating how to use the TI-84 Plus Silver Edition calculator to calculate probabilities and x-values dealing with the non-standard normal distribution. In section 6.2, we discuss applications of normal distribution. In 6.1, we dealt with standard normal distributions. Recall from the previous section, standard normal distributions have a mean of 0 located at the center of the graph and a standard deviation of 1. In this section, we deal with applications of the normal distribution, where the mean located at the center is not 0 and the standard deviation is not 1. The mean and the standard deviation will always be given in the problem. So in this section, there are still two main concepts: calculating probabilities, percents, or area under the curve. That's one concept. And the other concept is calculating the random variable. Well, when we're dealing with the standard normal distribution, think standardized scores, the random variable is a z-score. In this section, the random variable will not be a z-score, it will be an x-value. And so, let's begin with our first example. The average salary for a Louisiana professor is $56,900. If the average salaries are normally distributed with a standard deviation of $8,500, find the following if one professor is randomly selected. Find the probability that the professor makes more than $45,000. Well, I went ahead and drew a normal distribution here. Notice here our random variable is x. X in this case represents the professor's salary. And so the mean is $56,900 located at the center of the graph. And the standard deviation is $8,500. And so we want to know the probability if we randomly select one Louisiana professor that their salary is more than $45,000. Well, the mean is $56,900. So 45 is less than that. It's going to go on the left side of the graph. And we want to find the probability that they make more than this amount. So we're going to start at the 45,000 and shade the right region of the graph. And so here, the probability that your random variable x, or that the salary is more than 45,000, is equal to, and here we're calculating a probability. So anytime we're calculating a probability, an area, or a percent, we use normal CDF. So normal CDF, you need your lower bound, your upper bound, your mean, and your standard deviation. Well, remember, to get your lower bound and upper bound, you look at the graph. You read the graph from left to right. So the shading starts here at 45,000 and continues in this direction towards positive infinity because the graph never ends. So what we use to represent positive infinity is a very large number. So our lower bound would be 45,000. The upper bound would be that really large number. We use 6 nines to represent that really large number. Your mean, which is 56,900, and your standard deviation is 8,500. So you go to your calculator, press second, open up your distribution menu by pressing variables, go down 1 to number 2 and press normal CDF, press enter. And so let's clear this out. We have our lower bound, 45,000. The upper bound, the mean, and the standard deviation is 8,500. Press enter and then enter again. So the probability of randomly selecting one professor who makes more than 45,000 is approximately 0.9192. Basically, about 91% of professors make more than $45,000. Second example. Find the probability if you randomly select one Louisiana professor that they make between $42,000 and $47,000. Well, here the mean is $56,900, and so 42 and 47,000 are both below the mean, so we're going to put 42 here, 47 here, and we're going to shade this little region. We're trying to find this area under the curve. And so we're looking for the probability that the salary is between 42,000 and 47,000. So once again, we use normal CDF. We need a lower bound, an upper bound, a mean, and a standard deviation. So reading the shaded region or the graph from left to right, the lower bound would be this 42,000, and then the shading stops at 47,000. So the order, remember, is important. 42,000 is the lower bound, 47 is the upper bound, the mean and the standard deviation, that's given in the problem. So you go to second, variables, to open up your distribution menu, go down to normal CDF, press enter. So 42,000, 47,000 is your upper bound. Your mean is 56,900, and your standard deviation is 8,500. Press enter, enter, and so approximately 0.0823. So there's kind of two ways of thinking of this. The probability of selecting a professor, a Louisiana professor who makes between $42,000 and $47,000 is 0.0823, rounding to 4 decimal places. Or you can also say about 8.23% of Louisiana professors make between $42,000 and $47,000. Next question. Find the probability that the professor makes less than $48,000. Well, our mean is 56,900. 48 is less than that, so you put that on the left side of the graph. And we want to find the probability that a professor makes less than that amount. So you're going to shade all the salaries less than 48,000. So that's this side of the graph here, the left region. And so we're looking for the probability that the X value, or the salary, is less than 48,000. So we use normal CDF because we're looking for a probability. And we read the graph from left to right. So the left side of the graph continues forever, so we consider that negative infinity. And to represent that, we use a very negative number, so we use negative 999,999. And as we read it to the right, the shaded region stops at 48,000. That would be my upper bound. 48,000, the mean, and the standard deviation. So you go to second, variables, go down to normal CDF, press enter. Your lower bound would be negative 999,999. Your upper bound would be 48,000. Your mean and your standard deviation stayed the same. Press enter, enter, enter again. And so you end up with approximately 0.1475. So the probability of randomly selecting one professor who makes less than $48,000 is 0.1475. And so that's it for this part of the video.